All right, this is 1.3, solving equations. So we start off with, we call a statement where two expressions are equal, so the key word here being equal, we call that an equation. Okay, so an expression is something that has terms and variables, but there's no equal sign. So an expression, no equal sign. Equation has an equal sign. Okay, and a solution to the equation is all of the values of the variable that make the equation true. When solving equations, it's important to use operations that undo each other, called inverse operations. In this lesson, we will explore equations that are true for every value of a variable, which is known as identities. And we will see equations that use at least two different letters as variables, called literal equations. All right, so we're going to go ahead and start with some properties of equality. You guys should have learned these in geometry, especially when we did proofs. We did a lot of these properties and used a lot of them. You also would have learned these in Algebra 1. All right, so the first one's the reflexive property. So the reflexive property, I think of reflection. If I look in the mirror, I look back. If A looks in the mirror, A looks back. If 4 looks in the mirror, 4 looks back. So that's the reflexive property. The next one's symmetric. Symmetric is if A equals B, then B equals A. So if 3 equals X, we're allowed to flip-flop those. Then X equals 3. Transitive. For the transitive, I think of a train. So it says if A equals B and B equals C, then A equals C. So you're allowed to connect the front of the train to the back of the train as long as the middle section is the same. So since it goes through B, I can now connect A to C. All right, so if I said if 4 plus 3 equals 7, and let's say 7 equals X, then I can say, take the front, 4 plus 3, connect it to the back. You're allowed to connect it as long as the middle is the same. So my conclusion to this statement would say then 4 plus 3 is equal to X. All right, substitution. If A equals B, then you can replace A with B or vice versa at any point in time. So if, let's say, X equals Y, and 5 plus X equals 9, then I can use substitution and say 5 plus Y equals 9, because we know X and Y are the same, so I can substitute them in, I can replace them with one another. All right, so we're going to go ahead and solve some one-step equations. So again, the whole goal of solving equations is to isolate or get the variable by itself. So your first step is identify where is your variable, and then identify, well, what is with your variable and how can you get rid of it by using these inverse operations. So if something's being added, I have to subtract. If something's being multiplied, I have to divide. So I have X plus 9 equals 15. Well, I can clearly see that there's a 9 with my X, and it's being added to my X, so we need to do the inverse or the opposite of adding 9, and we need to subtract 9. Remember, whatever you do to one side of the equal sign, you must do to the other side of the equal sign as well. So now I get 9 minus 9, 0, so I have X plus 0. We don't have to put that, just put X equals, and then you do negative 15 minus 9, which would give me negative 24. And now my variable is by itself, X is all alone, and it equals negative 24. Next one, identify where B is, and what is happening to B? B is being multiplied by 12, So the opposite of multiplying by 12 would be dividing by 12. Alright, so let's divide each side. 12 divided by 12 is 1, so this is 1 times b. Well, 1 times b is just b. Equals 18 divided by 12. That is not a pretty division, so we will leave it as 18 over 12, except you must reduce. So when we reduce things, we're asking ourselves, is there a number that can go into 12 that can also go into 18? So just thinking about this, well, 2 goes into both, but you want to find the biggest number. So 2 works. We could do 2. We just might have to reduce some more. And then let's go bigger. 6, right? 6 goes into both of these. So I'm doing 18 divided by 6, which would give me 3. I would do 12 divided by 6, which gives me 2. Look at 3 and 2. Is there any number that goes into 2 and into 3? Nope. So this is in simplest form. So your answer would be 3/2. All right, let's go ahead and move to the next page. Okay, so now we're going to work on a 2-step equation, meaning that there's going to be 2 steps before I get the variable by itself. Okay, so step 1, identify where the variable is. So the variable is with that -3. So step 1 is to get that -3y term. So remember, terms are separated by pluses and minuses. So this right here is a term, this is another term. So you want to get this term by itself, and then once it's by itself, then you're able to divide by that -3. Okay, so step 1, isolate the term. Step 2, get y by itself. So to isolate, I'm going to have to subtract 7.4 from both sides. All right, so now I'm going to have a -3y. 7.4 minus 7.4 is 0. I don't have to put plus 0. Equals, subtracting decimals, line up the decimals, subtract. So 9 minus 4, going to give me that 5. 20 minus 7, that's going to go ahead and give me 13. And so now I have 13.5. All right, next step, get y by itself. It's being multiplied by -3. The opposite thing of multiplying by -3 would be divided by -3. So now we have to go ahead and divide each side by this -3. All right, so I'm going to get -3 divided by -3 is 1. 1 times y, y. So I have solved for y. Let's go to this side over here. I will show you guys how I like to divide my fractions, so you don't have to like go over here and do the whole long division house thingy. So dividing by fractions is actually pretty simple when it looks like this. So the first thing I'm just going to pay attention to is my answer going to be positive or negative? So this is a positive divided by a negative, so my answer is going to be negative. Okay, now we can ignore the negative. So now you just ask yourself, okay, how many times can 3 go into 1? Well, 3 can't go into 1, so you move over 1. So I go 3, how many times can 3 go into 12 or into 13? Well, 3 can go into 12 4 times. So that's what we're going to do. So we're going to put a 4. Okay, so 3 times 4 is 12, but this is 13, so I'm going to have a remainder of 1. So then I take that 1 and I just put it right down here. That's my remainder 1. And now I go, all right, how many times can 3 go into 1 and 5, which is 15? So how many times can 3 go into 15? Well, 3 can go into 15 5 times. Okay? Only thing we have to be a little careful about is that there is 1 decimal place, so we need to make sure we include 1 decimal place. So it would be -4.5. All right, next one. 2/3 y is what I need to isolate first. So step 1, I'm going to go ahead and add 7 to both sides. So I get 2/3 y equals 5 plus 7, 12. Okay, this is where sometimes you guys like to do this in 2 steps. We want to be like as efficient as possible, so let's not do this in 2 steps. So when you have a fraction, to get rid of the fraction or to make it 1, you multiply by its reciprocal. So to get rid of this fraction, I have to multiply by the reciprocal. When I do so, the 2 and the 2 will cancel, the 3 and the 3 will simplify. So now this is just 1, and I get a 1y. Okay, I have to do the same to the other side, so I need to multiply this one by 3/2. Go ahead, simplify if you can. The 2 and the 12 will simplify, and this will give me a 6. So what I am left with, I'm left with a y equals 6 times 3, and 6 times 3 is 18. All right, solving equations with grouping symbols. All right, so hopefully you guys look at the first one and you identify what you have to do. You have a 3m plus 5. You're supposed to do parentheses first. Well, I can't add together 3m plus 5. They are not like terms, can't add them together. So there's nothing that can happen inside those parentheses. But I do notice that there's a 4 on the outside that needs to be multiplied to everything inside of the parentheses. So step 1 would be distribute. All right, so let's multiply. 4 times 3 gives me 12, so this is 12m, plus 4 times 5. 4 times 5 is going to give me a 20, equals 56. Now you have your basic two-step equation. Isolate the 12m first, so I need to subtract 20 from both sides. So I get 12m equals 56 minus 20, 36. All right. I have a 12 being multiplied to my m. Opposite of multiplying by 12 would be dividing by 12. So divide each side by 12. Those are going to simplify and give me 1. So I have 1 times m, which is m, equals 36 divided by 12. How many times does 12 go into 36? 3 times. All right, next one also has distribute. So let's go ahead and distribute that first. So I'm going to get 17 times 2 gives me a 14y. And then I'm going to get 7 times this negative 5. That's going to give me a negative, and 7 times 5 is 35. And then you still have this minus 8y. So just keep it out there. Equals 1. All right, I'm going to go ahead and combine my like terms. So 14y and negative 8y, those are like because they both have a y. So I can combine those. So 14 minus 8 would give me 6. So I have 6 y's minus that 35 equals 1. Now we're down to that two-step equation again. So we're going to go ahead and add 35 to both sides. So now I get 6y equals 36. Final step to get y by itself, we need to divide by 6. So we get y equals 6. All right. Okay, so you guys have this like crazy stress thing about fractions. Fractions are amazing. Like they're way better than decimals. I know you guys are all right now listening to this video and saying, no, Miss Christensen, they are not. But they really are. Like fractions are so much easier than decimals. I would much rather look at this and see 1/3 instead of 0.3 repeating, okay? Fractions are just division. 1/3 is just saying divide by 3. Super easy. So when I distribute this 1/3, when I'm multiplying by a 1/3, it's really saying divide everything by 3. All right, well, I can easily do that. So this is saying, well, what's 9 divided by 3? And we know 9 divided by 3 is 3w. Over here, positive 15 divided by 3 is going to give me 5. And why don't you look at that? That's so much better and so much easier than trying to sit here and go, okay, what's 0.3333 times 9? And then what's 15 times 0.3333? Yeah, no, not nice, not pretty. We don't like it. I despise decimals. So we're always going to use fractions, and we're going to learn to love fractions. This is the year you're going to love fractions. All right, easy two-step equation again. I'm going to go ahead and subtract 5 from both sides. So I get 3w equals, and that's going to go ahead and give me a negative 12. Divide each side by 3. Be careful, w equals positive divided by, or a negative divided by a positive is going to give me a negative. 12 divided by 3 is 4, so I get negative 4. All right, these ones say more difficult, but are they really? No. So this first one, if you guys notice, there's parentheses on both sides, and there's something being multiplied to parentheses on both sides. So you're going to have to distribute both sides. So this is going to have to distribute, and this is going to have to distribute. So let's go ahead and do that. Negative 3 times 2 is going to give me a negative 6k. Negative 3 times 5 is going to give me a negative 15 equals negative 9 times k, negative 9k. Negative 9 times positive 4 is negative 36. All right. Okay, so a little bit different. I have k's on both sides, and I need to have k's just on one side. So I always like to move the k that is going to give me a positive number. So should I go ahead and add 6k to both sides and then I get negative 3k? Or should I add 9k to both sides and then I'll get a positive 3k? So we want to move that. We want to add 9k so it ends up being positive. So I'm going to go ahead and add 9k to both sides. All right, so I have negative 6k plus 9k gives me a positive 3k minus 15 equals negative 36. All right, isolate this k over here. I need to add 15 to both sides. So now I'm going to get 3k equals, and that's going to give me, what, negative 21? All right, divide each side by 3. So I get k equals negative divided by positive is a negative. 21 divided by 3, 7, negative 7. All right, a little bit more complex. This one is a little tricky, and you guys do make this mistake quite often. We're using distributive, so I need to distribute. Here's where you make the mistake. When you distribute, you have to distribute the negative as well. Huge mistake. You guys forget the negative, and then everything's wrong. So you want to multiply by negative 2 to get it correct. Okay, so distribute the negative. All right, let's work it out. So 3 times 2, 6x, 3 times negative 1, negative 3. Negative 2 times 3x is going to give me a negative 6x, and then negative 2 times positive 4, negative 8, equals 11x. All right, let's go ahead and combine my like terms. So if you guys notice, I have 6x, negative 6x. I have negative 3, negative 8. So we're going to go ahead and combine those. 6x and negative 6x, those just cancel each other out. Negative 3 and negative 8, that gives me negative 11 equals 11x. We want to get x by itself. Right now it's being multiplied by 11, so I need to divide each side by this 11. And then I'm going to get negative 11 divided by 11 is negative 1 equals x. Using that symmetric property, flip it around because I don't like it in that form. So we get x equals negative 1. All right, moving on. Okay, so looking at this one, again, you guys look at this and you go, oh my gosh, it's so scary because there's fractions and it's terrifying. One method that we like to use to get rid of fractions, like if you hate fractions, clear the fraction. So what that means is you look at your denominator and you find the least common multiple of the denominator. So I'm looking at 4 and 8. What is the smallest number that 4 can go into and 8 can go into? Hopefully you guys are saying, well, 4 can go into 8 and 8 can go into 8, so my least common multiple is 8. So if you hate fractions, let's clear the fraction. So you're just going to multiply this entire thing by 8. Actually, I'm going to show you this on both sides. Let's erase that real quick. Okay. So I'll multiply this side by 8, and I'll multiply this side by 8. Hopefully that's a little better for you guys. All right, now simplify. The 8 and the 8 will simplify. This 4 and 8 will simplify, and this will be left with a 2. And now it's not scary. Okay, so I'm going to rewrite this so we don't make a mistake. So now I have 2, and then you have to multiply 2 times this whole thing. 2x minus 5 equals, and then on this side I have just -3 because those canceled, -3. And now it's not scary, you know how to handle it, it's not a big deal. So let's go ahead and distribute. So I'm going to get 4x minus 10 equals -3. Back to our basic two steps. Add 10, add 10. So I get 4x equals 7. Divide by 4, divide by 4. Do not ever give me an answer that is a decimal unless the whole question was in decimals. You leave everything as fractions, and you do not have to turn it into a proper fraction. Like, don't waste your time. So your answer to this is, if you can simplify, simplify, but nothing else. 7/4, that's the answer. Don't do extra work. Don't do extra work. All right, sliding on down to some lovely word problems, because we all love word problems so much. I hate word problems. I hated them as a student. I still hate them to this day. But they're actually useful for real life stuff, of course. All right, so here we go. A formal garden can incorporate hundreds of thousands of brightly colored flowers as well as grass, gravel, and fountains to form designs. Suppose a garden has a perimeter of 320 meters. What would the dimensions of the garden be if the length is 3 times the width? All right, so let's go ahead and draw ourselves a garden. So first word we need to identify is perimeter. Hopefully you guys remember perimeter is distance around the outside. Okay, and then we want to find the dimensions of this. So let's go ahead, draw ourselves a nice little rectangle. Beautiful. I know yours looks just as perfect as mine, obviously. Okay, so we know that the length is 3 times the width. So let's just call this width W for width. And we know this length is 3 times the width. So 3W, 3 times width. Width is W, 3 times W. Okay, so we're looking good. And then we know the perimeter around this is 320. So that's how we're going to be able to figure it out. So we know that this side would also be W, and this side would also be 3W. And if I add all of this together, I'm going to go ahead and get the perimeter, which is 320. So let's set up our problem. So I'm going to have 2 W's plus, and then there's 2 3W's, so 2 times 3W, or you guys could have just done that in your head, equals 320. Let's go ahead and simplify. I have 2W plus 6W equals 320. I have 8W equals 320. Let's go ahead and divide each side by 8. So I get console, so that's a W, equals 8 goes into 32 4 times. There's an extra 0, put the 0. 40 times. So the width of this garden is 40. Easy enough. So we know the garden is 40, put your units, meters, by, and then this one's 3 times W, well W is 40, so it's 3 times 40, which is 120 meters. So this would be my answer. The garden is 40 meters by 120 meters. Moving on down, some more word problems. All right, so it says solve each literal equation for the specified variable. A literal equation just means 2 variables. Easy enough. So it says standard form of a line is ax plus by equals c. We want to solve this for y. So in other words, we want to isolate y. I want to get this guy by itself. All right, Again, this is just a regular equation. It's nothing too difficult, nothing we don't know how to handle. So let's go ahead. I'm going to rewrite it over here. Oh, wrong color. So we have ax plus by equals c. Okay, we're getting y by itself. First thing I need to do is I need to subtract ax from both sides, trying to isolate the term. Alright, so now I'm just left with the by equals, I'm going to put, I like the a first because that's a variable, so I'm going to put negative ax plus c. So hopefully that makes sense for everyone. Okay, last step to get b by itself. To get y by itself. B is being multiplied to y, so the opposite of multiplying is I need to divide everything by b. Everything by b. So I get y equals, I'm going to go ahead and separate these. So I'm going to have negative a over b x plus c over b. Hopefully you guys realize this is in this is in slope-intercept form, right? Going back to algebra and all those lines we did. So this would be your m, and this would be your, so remember it goes mx plus b, m being your slope, b being your y-intercept. So we know our slope of this line is negative a over b, and we know our intercept, or b, is c over b. So again, if you guys forgot about this, this is your slope, and this is your intercept. This is your y-intercept. Perfect. Alright, next one. The equation K equals C plus 273 relates to temperature for two different scales. K is Kelvin, C is Celsius in degrees. What is C in terms of K? What is C in terms of K? So the hardest part about any word problem is just what are they asking me, right? I want to know what is C. So that means solve for C. What is C? Solve for C. So this one's actually like extremely simple, because I have K equals C plus 273. We want to get C by itself. We want this guy by itself. So how do I get C by itself? Well, let's go ahead and subtract 273 from both sides. So I get K minus 273 equals C. So this is C in terms of K. Of course, I don't like the way that's written, so let's go ahead and rewrite this. So C equals K minus 273. It's not too scary, hopefully. All right, let's go to our last page. Oh, this is fun. It wants to know, is this always, sometimes, or never true? Is this always, sometimes, or never true? All right, let's go ahead and solve. So first we want to go ahead and simplify both of these sides and figure out, is this always true, never true, or sometimes true? So start by simplifying. Step one, I'm going to go ahead and combine my like terms. Over here it's this and this. Okay, so I'm going to start by combining like terms. So I have 7x minus 4x. That's going to give me a 3x plus 6 equals, and then I'm going to get 12 minus 8 is 4 plus 3x. All right, let's go ahead and move our x's to the same side. So I'll move this one. Minus 3x, minus 3x. Hopefully you guys realize what's going to happen here. These are both going to cancel. So I'm going to get 6 equals 4. So is 6 always equal to 4? Is 6 sometimes equal to 4? Or is 6 never equal to 4? And hopefully this is very obvious. 6 does not equal 4. So this is never true. Never, ever, 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 ever true. All right, let's go ahead and try the other side. Or B, let's try B. Hopefully you guys realize there's some distributive properties here. So let's go ahead and make sure we distribute. So I'm gonna get 2x plus 3x minus 12 equals 4x minus 12 plus x. Okay, so I just distributed that all out. Let's go ahead and combine our like terms. So these can combine on this side and this can combine on that side. So I'm going to have 2x plus 3x, 5x minus 12 equals 4x plus x gives me a 5x minus 12. We can stop right here. Is this true? Like 5x minus 12 is equal to 5x minus 12? Well, yeah. Is 5x minus 12 always going to be equal to 5x minus 12? Yes. So this one is going to be a always true. And that concludes our 1.3 notes.